So to recap the timeline, we used our microcontroller, the Arduino Uno or the Wemos R32 to send readings. Initially we started off sending readings to Adafruit.io, which is basically a third-party platform. And we were actually sending the readings to Adafruit's broker server. And we understood what was a broker server. It's just a temporary repository that contains what's called as feeds or topics or channels. So we were essentially publishing to topics on Adafruit's broker server. With time, we realized that there was a problem, which basically, if you have a free account on Adafruit, then you would have a limited storage. If we exceeded that limit, we can either delete some rows, delete some readings that has been sent, or delete an entire feed. And then we started sending, we made another separate script to send data to another database. We chose Firebase for that, which was actually just a real-time database. It's not like the SQL-based databases. It's not a relational database, but it's something like a JSON-like database, or it has like trees of JSON objects. So we sent values to Firebase in a separate script. The other problem started to appear when we combined the code that sends the values to Firebase with the code that sends values to Adafruit in the same script, and we uploaded that script to the microcontroller. We saw that the processing speed was a little bit slower. It isn't as fast as sending data to each destination of these individually. The solution we adopted was by limiting the destination that the microcontroller is sending values to. So instead of sending values to multiple destinations simultaneously, we are going to limit the microcontroller to send the values to only one place. And from that one place, we are going to figure out a way to forward the data to another destinations as much as we desire. And the logical thinking was, if we were using the Mqtt protocol, then with the same technique that Adafruit is working, we can actually see a way or check a way to download and install our own Mqtt broker server, which is going to be receiving the values that we are going to publish from the microcontroller over Mqtt. And we found out that there was Mqtt. That piece of software was a standalone Mqtt broker server that we could have downloaded and installed locally on our laptops. But we thought of the following: if we did this, if we installed this Mqtt broker server on our laptops, we actually wouldn't be able to access these values or this dashboard that is going to be created afterwards unless the laptop is always up and running. So, and instead of doing anything locally, we reserved to the cloud. So we went to AWS and we spun up a VM or an instance, and inside that instance we installed Mqtt, which is the Mqtt broker, and we started sending data to this Mqtt broker server. And the data that has been sent to Mqtt, we found out that there is actually only two ways to listen to the data being sent to the Mqtt broker server, which is either using something called a desktop application that is called Mqtt Lens, where we just are going to subscribe to the topics on the Mqtt broker server and see the values that is being sent in real time, or use a mobile application, which is basically similar to this Mqtt Lens, but it's just in mobile. That is going to do the same thing, and from that mobile application we are going to subscribe to the topics and create dashboards, and this is it. So we didn't actually found it flexible after the point that the data has been sent to the Mqtt broker server. So we had one of two options: either by manually writing scripts in Python and PHP and Node.js, and manually writing code that is going to be handling or subscribing to the topics from the Mqtt broker server, which we are publishing from the microcontroller, and the data that is being subscribed by our code that is going to be manually written in these scripts is going to be fetched and handled and sent to another or forwarded to other destinations. This would have been a little bit annoying, since we are going to do everything from scratch. So instead of writing anything or writing any extra code, we resorted to Node-RED, which is basically a data bridge and a flow-based programming platform, where we created nodes that listened or subscribed to the topics which we have created on that Mqtt broker server, which was actually receiving the values from the microcontroller, and from that nodes that have been subscribed to these topics on Node-RED, we took these values from these nodes and forwarded them to multiple destinations. We forwarded them to Firebase, to Adafruit, and Eft. The solution we adopted was by limiting the destination that the microcontroller is sending values to. So instead of sending values to multiple destinations simultaneously, we are going to limit the microcontroller to send the values to only one place. And from that one place, we are going to figure out a way to forward the data to another destinations as much as we desire. And the logical thinking was, if we were using the Mqtt protocol, then with the same technique that Adafruit is working, we can actually see a way or check a way to download and install our own Mqtt broker server, which is going to be receiving the values that we are going to publish from the microcontroller over Mqtt. And we found out that there was Mqtt. That piece of software was a standalone Mqtt broker server that we could have downloaded and installed locally on our laptops. But we thought of the following: if we installed this Mqtt broker server on our laptops, we actually wouldn't be able to access these values or this dashboard that is going to be created afterwards unless the laptop is always up and running. So, and instead of doing anything locally, we reserved to the cloud. So we went to AWS and we spun up a VM or an instance, and inside that instance we installed Mqtt, which is the Mqtt broker, and we started sending data to this Mqtt broker server. And the data that has been sent to Mqtt, we found out that there is actually only two ways to listen to the data being sent to the Mqtt broker server, which is either using something called a desktop application that is called Mqtt Lens, where we just are going to subscribe to the topics on the Mqtt broker server and see the values that is being sent in real time, or use a mobile application, which is basically similar to this Mqtt Lens, but it's just in mobile. That is going to do the same thing, and from that mobile application we are going to subscribe to the topics and create dashboards, and this is it. So we didn't actually found it flexible after the point that the data has been sent to the Mqtt broker server. So we had one of two options: either by manually writing scripts in Python and PHP and Node.js, and manually writing code that is going to be handling or subscribing to the topics from the Mqtt broker server, which we are publishing from the microcontroller, and the data that is being subscribed by our code that is going to be manually written in these scripts is going to be fetched and handled and sent to another or forwarded to other destinations. This would have been a little bit annoying, since we are going to do everything from scratch. So instead of writing anything or writing any extra code, we resorted to Node-RED, which is basically a data bridge and a flow-based programming platform, where we created nodes that listened or subscribed to the topics which we have created on that Mqtt broker server, which was actually receiving the values from the microcontroller, and from that nodes that have been subscribed to these topics on Node-RED, we took these values from these nodes and forwarded them to multiple destinations. We forwarded them to Firebase, to Adafruit, and Eft. And this was how our flow looked like in Node-RED. So this is the node that was subscribing to a topic that we have created on the Mqtt that we have named as light, which is basically receiving the data that is coming from the microcontroller and publishing and being published there. And the values that is being received is being sent to the dashboard that we have created, being debugged, and we can see it here, being sent to another dashboard that we have created, being sent to Adafruit, to Firebase, I'm sorry, and being sent to Adafruit as well. And finally, we send the same data to Eft events, or F web services to make a phone call or send an email by exceeding a specific cutoff value. In this lab, what we are going to do extra is that we are going to send or forward data from Node-RED into MySQL. And if you don't know what MySQL is, I'm going to go through the terminologies real quick right now. But you need to understand that we are going to create our own structured relational tables, and we are going to send data from Node-RED to these tables. Alright, so let's just recap what we did in Node-RED. So far in the flow, we had the subscription node that takes the values from a topic that is called light, which we created on Mqtt, which we are sending the readings or the light readings from the sensor via the Arduino or the WebOS2. So we are subscribed to that topic, which is basically represented this area here. So we are subscribed to this topic from the Mqtt broker, and whatever values that is coming from the Arduino or the microcontroller to that topic's broker, the Node-RED is receiving it via the subscription node that we have here. And it happens that the topic is called light, and this is something that we created. Whatever values that are reaching this node is being transferred or forwarded to multiple places. Here we are forwarding it to 2 dashboard nodes, and we are forwarding these values to a debugging node here. So you should see the values here, but I'm not running the circuit yet. We are also sending the data to Firebase and to Adafruit, and finally we send the data as well to F web services to make a phone call or to send an email if the cutoff value has been has exceeded some certain threshold. Okay, so before we get started in describing the terminologies that you have, which is basically MySQL or Php Admin and My Sql Server and Apache, I'm just going to make sure that the circuit that I have is working. So I'm just going to go to the code here. Notice that the code that I'm using is basically, I'm using the ESP01, so this is the code for the ESP01. If you have your code running on WebOS, then use that code. It happens that I don't have the WebOS with me, I just have the ESP01. I'm just going to edit the SSID and the password, so you can go ahead and do that. I'm going to set my broker server, which is basically where the broker is installed, which is basically the AWS instance IP address. So I'm just going to go to my AWS console. Oh, let me just go from there. I'm going to go to the EC2 instances, and here running instances. I'm just going to go to pick this one for this session, and you can find the IP address here. So check the IP address of your instance and make sure that the region that you have set is correct. So I have all of my instances in Virginia. So I'm just going to copy this IP address and go to the code and place this here, and I'm going to connect the Arduino and then upload the code. Alright, let's just open up the serial monitor here real quick. So we are connected to the network and connected to the broker, and the values should be sent to the broker. Let's make sure that the values are received by the broker. So I'm just going to go to the MQTT lens. I don't really remember which connection did I make for this IP address, but I think it's IoT server lab 4. Let me just check. No, this is not the same IP address. Maybe this one. Not this one. Let's check the last one. Yes, this is the IP address that we are working on. 133. Alright, so IoT lab 5 IT Server Lab 5, it's here. So we should see the messages coming into this area here. Let me just make sure that it's running, so it's connected. So let's make sure that the topic is written correctly. So this is the light topic. Yes, you can see the messages here. Actually, it's being received. It's incrementing here. So these are the messages that I'm actually sending from the microcontroller, and the same messages as being are being delivered or received by the broker on our AWS instance. Right? So everything is working. We can go to the dashboard and make sure that everything is working as well. So I'm just going to go to this IP address and just go to the UI route. Okay, and you should see the values being received there. So I'm just going to play a little bit just to demonstrate that the values are being received correctly. So let's try to increase the intensity. Yeah, it's working. Alright. So let's understand the terminologies that we have mentioned earlier. What is My Sql Server? What is Phpmyadmin? What is Apache? These are the three essential parts that we are going to deal with. So you need to understand exactly what each one actually does, because we are going to install these three. And the installation part is just copying and pasting some instructions. So it's not going to be that hard. But the most important part is understanding why are we installing these on our AWS instance. So let's start with MySQL first. MySQL is what we call an RDBMS, or a relational database management system. And the word relational, by now you should understand that relational, if you I think you've seen this in your database course or module. So relational just means that we have a bunch of tables. This is what relational means. But the most important part is this, DBMS. So MySQL is a DBMS, or a database management system, which means that this is the system, this is where we can create databases, create tables, and this is where all of these tables and databases are stored in. And vice versa, if you want to access these tables and databases, you need to have them stored in one place, in one logical place first, and this place is the DBMS, or the system, or the MySQL here. Alright, and you can tell now that if you want to access the databases or the tables, you need to have this MySQL server, or this MySQL piece of software, whatever the analogy is. It's to be running all the time. You need it to be running all the time, available all the time, hosted all the time. So this service here, this DBMS, this service here, this MySQL, needs to be always running, whether on our machines locally or on anywhere on the cloud, on AWS instance like the one that we have spun up in the previous labs. It doesn't really matter. What matters is that this MySQL service, this DBMS, needs to be available all the time. So it's a service by the end of the day. So this means that this needs to be running all the time on some machine, right? And interchangeably, you can either call this a DBMS or a database server. So I don't want the word server to actually confuse you. The word server just means that this is just a service that allows you to access the databases and tables. Just like the Node-RED. Node-RED is a service. If you remember the layout that we have here, Node-RED is a service. And in order to access Node-RED, in order for Node-RED to be able to forward data all the time, whatever any value that comes to the topics that Node-RED is subscribed to, which is basically here in this node here, right? So whatever a value comes from the microcontroller to the Mqtt, it's going to be fetched and cached by this subscription node here in Node-RED. So whenever any value comes, in order for Node-RED to be able to send data to whatever destination that we set in these nodes, this means that Node-RED needs to be running all the time. So Node-RED is a service that needs to be running all the time. And like any service, like any server, for a service to be running all the time, it needs to allocate some certain part in your machine just dedicated to hosting or running this service, okay? And it happens that this part in our machine, on AWS, it found to be this port number, just 1880. This is the port number that the developers for Node-RED chose, that whenever anyone who wants to run Node-RED on their machines, if you want to have Node-RED always running, please just make sure that this port is available in your machine. And if that's available, then Node-RED is going to be running all the time on this port. So this service is going to be up and running and available for us, available for any data that comes to the topics, so it can forward it to any place, right? And the same thing for the Mqtt. We found that the Mqtt have this port number, 1883. It runs on this service, it runs on this port. So if you want to have the Mqtt broker server always listening to whatever values that you are publishing to its topics, you need to have this port available on your machine, whether this machine again is a cloud instance or a local machine. So this port needs to be open always, all the time. And this is why the main reason where we went to our security groups and configured the impound rules to have always the 1883 for the Mqtt and the 1880 for the Node-RED always opened, right? So we opened these ports, we opened a rule in our security group for these ports to always be available. So whenever a piece of software or a service wants to allocate these ports in order to run on our machines, they should find these ports opened, since we are actually opened rule for them in this security group. Okay, so again, going back to our MySQL. So bottom line is, MySQL is just a system that contains databases and tables where we can access these databases and tables, modify them, add columns to them, add new tables, create new databases, drop or delete entire columns or databases. It's totally up to us. So this system needs to be running all the time, since it's a service. Okay, since you want it to be accessible all the time, so make sure that there is a port for this service that is going to be opened all the time for this service. And it turns out that this service actually uses a port called 3306, and that's a very common conventional port for most of the database management systems, whether you are using Oracle, Workbench. Most of the tools use this port. Okay, so we are going to open this port, or open a rule in our security group for this port, in order for this software actually, in order for it to run smoothly and all the time on our machine. We are going to open up a rule in our security group under this port number. So whenever this service runs, it is going to find that this is the port for it, and the port is opened since we actually made a rule for it to make it open, and then the service is going to be running all the time. But the catch here is you can't really use MySQL like this easily from the command line. Remember, in Python, we can use Python from the command line like this. So in Python, we can use the command line like this. Now, I've written just Python, and now I entered what we call a Python shell, or the Python command line. And I can write whatever Python syntax that I want to write. So this is, for example, a print statement, right? And I can do whatever I want, but things are going to be a little bit ugly the minute that you write multi-line syntax or multi-line commands. For example, you want to define a function. If you want to define the function in this command line, in this shell, it's going to be really ugly. So let's just define a function like this. And notice what I'm going to do right now. I'm going to go enter, and notice when I go enter, it's going to give you an error. So instead of doing that, we can just say and instead of doing this in the command line, I didn't actually wrote any multi-line codes before in our in the Python shell, so that's why it's going to be a little bit weird here. But anyways, if you want to write multi-line commands or multi-line Python scripts, what we used to do, we said that this Python shell is really cool. It's really flexible if you want to write some one-liners, if you want to test some functions or built-in methods. For one-liners, it's really beautiful. but whenever it gets to multi-line, things get a little bit annoying. So instead, we said that we use the editor, the IDE, whether it's Visual Studio Code or Atom or whatever IDE that you use in order to write Python scripts, multi-line Python scripts, and run these scripts. Now, maybe the analogy that I'm using is not logically correct, since I don't really mean to say that this Visual Studio Code is the interface. If you want to understand it this way, then that's fine, but this might not be logically correct. But what I want to say is that instead of using the Python shell in the command line, we used something like an interface to write more practical Python scripts. And that was the Visual Studio Code, or any editor, right? So this was the interface for me to write Python in. Alright, and instead of using the Python shell. The same thing happens with MySQL. You can use MySQL from the command line. So I can just type MySQL. Let me just say MySQL like this. Right, 1 second. Yeah, I remembered, yeah. So sudo MySQL u root b. Alright, so now we are inside the MySQL shell or the MySQL command line, and I think you have taken SQL commands or queries by now in your course. So if you want to create a table, you can just say create. It doesn't have to be capital letters, but I just like this convention. For example, the table name could be something like create table, that is going to be something like readings, for example. And you specify the column name, which is basically ID, and the type, and so on. And if you want to put any constraints, you can put these constraints. So you can do this here, right? So let me just make a very quick one here. I'm not going to call it readings. I'm going to call it customers, for example, because I will create another one called readings. So I'm just going to say that ID, and this is going to be my primary key. And let's say that I'm going to have a first name. I'm just going to have like 3 columns, varchar, which is basically the equivalent for strings in databases, and is name, this is the 3rd column, and the type of it, the type of values that it can store. Notice how things get really messy whenever you write like multi-line queries or long queries in general. Okay, so I think we need a semicolon. No database selected, so we need to select the database first. Alright, so the bottom line here, I'm not going to do anything in this MySQL command line. Everything that we are going to do it in something called Phpmyadmin, which is the interface that you use in order to interact with MySQL. Right? I just wanted to show you that if you want to use MySQL as it is, as it comes, whenever you install it, then you can use it from the command line like this. And this is going to be a little bit inflexible. It's not the best thing in the world, like working on the command line, not all the time, especially if you have like a script that has multiple queries on it. Alright, so instead of using the command line, I'm just going to hit Ctrl Z to exit that shell or the command line. And instead of using the command line for MySQL and using MySQL just the way that it comes in, we can use the interface for MySQL, which is basically something called Phpmyadmin. And again, the analogy that I'm using might not be the most correct thing in the world, but I just want you to understand the idea. So the same thing in Python, instead of using the Python shell, we use the interface to write multiple and more flexible Python scripts using the IDE, which is Visual Studio Code. The same thing with this MySQL. And instead of using MySQL on the command line and writing SQL queries on the command line, which is not that flexible, we can use an interface that allows us to write whatever SQL queries that we want to run in our databases and tables that are inside the MySQL DBMS. Right? But instead of writing these queries that actually manipulate the databases and tables inside MySQL DBMS, and instead of writing these queries inside MySQL command line, we can write the same exact queries like the one that I've just created here. I can write the same exact query in the interface, which is basically something called Phpmyadmin. So what is Phpmyadmin? So Phpmyadmin is just an application. It's just a piece of software. It's just a web application, and specifically it's written in PHP. And this actually justifies why it's called PHP at the beginning. Why not something like MySQL It would have made more sense, since since this application is the actual interface or the gateway to the MySQL databases and tables inside of it, right? But they called it Phpmyadmin for whatever the reason is, and this is just mainly, for me, I think this is because the web application is built based on PHP, all right? And this is how Phpmyadmin looks. So I'm just going to log in first. You can ignore these errors for now. And this is the table that I'm going to show you. How can we create something like that in just a second? So I created a table that I called, if you see the name here, the table is called readings. So this is the table that's called readings. You can neglect this left-hand side here. Edit and copy and delete is just some flexibilities that this Phpmyadmin is offering you. You can like delete the row, copy the row, edit the row. So for every row or instance in this table, you can do all of these operations. So you can neglect this part. What we care about is the column. So I have a column for the ID, the light reading that I'm receiving by the subscription node in Node-RED. Basically, this means that whatever reading that is coming, I'm going to create a node that is going to be related to MySQL, to this specific database that we're in, right? And any reading is going to be sent to that database, to this table. So the table is called readings, and the database is called sensors. And you can take a look at these from the left-hand side as well. So from the left-hand side, you have all of the databases listed. Some databases are just going to be there for you by default. So these are like default databases. Don't play with them. Just leave them as is, right? I created a database here called sensors. I'm going to show you how can you create one. Inside database, I just have one table, which is basically this relational table that is called readings. This one, right? And in this table, I have 4 columns: the ID, light reading, created at, and the sensor name. And note, these are not the only rows that I have. I probably have more than 10,000 rows in this table. I just don't want to show all of them, since it might crash the system, since they are really this is a really big table, right? But the bottom line is that this is how Phpmyadmin looks like. Okay, so Phpmyadmin is just, going back to this slide, is just a piece of software. It's just a web application, a PHP web application, right? So like any website, like any web application, like any website, a website needs to be hosted, right? It needs to be having some link, having some domain name that we can access, right? For example, look at AWS. AWS have this domain name, right? So you can access from this link, right? The same thing goes for Phpmyadmin. Phpmyadmin needs to be hosted on some server. It needs to be all the time running in order for us to be able to access it, right? So since MySQL, let's just take things a little bit from the beginning. MySQL is the DBMS that holds the databases and tables. It needs to always be running, since this is the service that is going to be always providing you with the tables and the databases that you have created. So in order for the databases and tables to be accessible all the time, to be available all the time, if we want to insert data to them, if we want to fetch data from them, then these tables and databases needs to be up and running all the time. And this means that the MySQL server, or the MySQL system that actually contains all of these databases and systems and tables, needs to be up and running all the time. So for this service to be up and running all the time, it requires the developers of this like MySQL server, they decided that this port number needs to be open for the usage of MySQL. All right, and for us to access MySQL, we can use the command line, and that's not going to be really flexible for us. So instead, we can use an interface that we can write all sort of queries, but instead of writing these queries in the command line of MySQL or the shell of MySQL, we can use that interface to be as a gateway, to work as a gateway or an interface to write our queries, and like make these queries reflect on the databases and tables in our MySQL DBMS, right? And maybe I didn't show you, but actually you can go to MySQL, to SQL part here, and write whatever queries that you want to write. For example, this query that I wanted to write in the command line, it can just copy it like this, right, and paste it here. Okay, and the minute that I hit enter, I should have a table called customer created. I'm not going to use it, I just wanted to show you that we can do that. Right, so instead of writing the queries in the command line, we can use the interface or the gateway to copy and paste or write these queries in, which is going to be reflecting on the databases or on the MySQL server or MySQL DBMS. Alright, and since MySQL service needs to be up and running all the time, the Phpmyadmin also, which is the website that is working as an interface for us to write the queries on, which is going to be reflected into the MySQL system, the Phpmyadmin needs to be up and running all the time as well. And like any website needs to have a domain name, needs to have some kind of link or an IP address so you can access it, right? Which means that any website needs to be hosted on a server, right? In order for us to be accessed, like I'm accessing Phpmyadmin via this route. This is the main route, right? So I'm just going to remove all of this. So this is the main route to access Phpmyadmin, right? So Phpmyadmin needs to be hosted on this machine, and this is the machine that I'm using currently. This is the AWS instance that I'm using currently, right? So it needs to be hosted in this machine for me to be able to access it, right? I hope that this is clear. We need this service to be always up and running, right? So we allocate a server port for it, all right? And we need this service as well, or this application to be up and running, which is working as an interface for us to access the MySQL, which as well is up and running in behind the scenes, right? So for us to host the Phpmyadmin, we can use something called Apache. So Apache, if MySQL was the database system that's related to databases and tables, it's called, most of the time it's called database server. Apache is a different kind of server. We have different kind of servers all the time. Generally in computing world, we have different kind of servers. So this is the database server, which is basically refers to the server that is going to be hosting and always giving you the tables or offering the tables and databases inside of it to make it accessible all the time for you. So this is called the database server. Apache is what we call a web server, and web servers are mostly used to host websites, since the name here, right? So web servers like Apache, this is the name of the web server that we are going to install. Apache is going to be the web server that is going to be making sure that the interface, which is Phpmyadmin, is always running, is hosted and always running in the background. So whenever we type Phpmyadmin like this, we should see all of this beautiful interface coming to us. And notice that if Apache wasn't running, if Apache wasn't even installed, then typing something like this in your browser will never get you anywhere, since the web application is not accessible. You need to run this web application. You need to make sure that the website is running, is hosted, it's accessible, by providing some kind of a web server that takes this website and provide hosting feature for it. Okay, so I hope that this is clear. So again, just to recap what we've said, MySQL is a system that contains databases and tables. In order to access it, you can use the command line, but that's not really flexible. So for better accessibility and usability, there is something called Phpmyadmin that the developers have made. Phpmyadmin isn't a server of any kind. It's just a website, as you're seeing it. That's just an interface. That's just a website. And like any website, websites needs to be hosted in order for them to be accessible like that. In order for me to be able to write the website name, like for example, to write the website name here and find some results coming back to me. Right? So websites need to be accessible, which means that they need to be hosted. And the piece of software that we are going to install is called Apache. And Apache is a web server. And from the word web, we understand that Apache provides the ability to host servers, to host websites, specifically PHP websites. or web application that are built on PHP. Okay, so we are going to use Apache to host the Phpmyadmin interface or gateway, right? And once we host that Phpmyadmin on Apache, Phpmyadmin is going to be accessible, and then we can access it from the web browser. And the minute that we can access the Phpmyadmin, we can say that now we have our interface ready, our gateway ready to reflect or modify or tinker with any database or table that is stored inside the MySQL DBMS. All right. So let's get started with installation. First of all, we're going to install Apache, then Phpmyadmin, and then MySQL. All of these on the AWS instance. Okay. And finally, once all of these are done, we are just going to go to Node-RED and install the MySQL plugin, since we need to actually connect from Node-RED to the database. And the plugin is going to show you this small icon. That's the node that we're going to have in our dashboard. Okay, so let's connect to the AWS instance via SSH first. Now, in order to connect to our AWS instance, we need to use SSH or remote connections to be able to access it and install whatever kind of software that we want to install. So I'm just going to go to Putty, and I think that you should have like one previously made profile or session here, but I have multiple because I've made multiple instances. So let me just check which session actually maps to this instance. I think it's connection to, yes, it's connection to, it has the IP address of 133, and this is the same IP address of the instance that we are dealing with here. So I'm just going to log in with Ubuntu. Now I'm going to use the first command to check what are the ports being allocated currently, or in other words, what are the services that are running on my machine currently. So I'm just going to right click here to paste this sudo else off here, and you can see that you have multiple services. So let's take a look at the first one. This is 1883, so this is the Mqtt. You can see that this is the name of the service, right? And this is 1880, this is the Node-RED, right? And this is the SSH, which is basically what we are doing. This is an SSH session we are using to remotely connect to the AWS instance. All right. Now let's first of all just make sure that all of the packages in the system are up to date. So I'm just going to right click here. It's going to take this some time, and it's done. Now let's install the first thing, which is basically Apache, that is going to be used to host Phpmyadmin, which is the application that is going to make MySQL DBMS accessible. So I'm just going to copy this and right click, hit yes and enter, or Y and enter. If it's done, let's take a look again, arrow up twice or thrice, to take a look at the services that we have. Now take a look at this service here. We have Apache. It's obvious that it's after it's installed, it's running, and Apache by default takes the port number of 80. I don't think that we have mentioned this. Maybe I forgot to mention that. Yeah, Apache needs to run on the port 80. By default, it takes this port, right? So this means, let me just show all of these. So this means that I will, in my SSH or in my AWS instance, in our inbound rules, this inbound rules, just to remind you, these are just something like a firewall, right? In this firewall on our AWS instance, we are going to open a port for 80 to make Apache accessible, and we are going to open a port for 3306 to make MySQL DBMS accessible as well here in just in a minute. All right, so let's just continue with the installation first. All right, so let's check the status of Apache. Right click, and it tells you that Apache is active, since actually we can see it. It's running. It's allocating this port. It's listening to this port. All right. Now let's type our instance IP address and check what is going to happen. Initially, if you have Apache running, let's just go to details here and copy the IP address. If you hit the IP address, no, I don't want this port. We don't really want this port. This is the port where Node-RED is running. We just want the IP address like that. So essentially, whenever you hit the IP address like this, you should see that Apache is telling you that it is running in the in the background. All right, but it's not going to show you anything in the time being. Why? The reason is that you are trying to access Apache that is installed on this machine, and this machine, this AWS instance here, will never provide you with any information unless you open up the port for the service that you want to access, which means that Apache runs on the service 80, right? So Apache runs on the service 80. So for me to be able to see Apache running on the browser, I need to tell my instance that, please, if I try to access Apache, which is in port 80 on you, just make that port available. And how can the machine tell you that? How can the machine make the port available? It's us who do this, actually. So we need to go to the security group and modify the impound rule and open up a new rule to make the port always available if I want to access it from the browser. Right? So I'm just going to security group like this. And in the impound rule, I'm going to hit edit impound rules, and let's add a new rule that is under the port 80, and here hit anywhere, right? And then just press on save rules. Now the instance, the AWS instance of ours, should be able to provide us with the Apache interface or the Apache web page. So let's refresh this now, and here you have, it's telling you the instance is actually responding to you with the service that is running under the port 80. Actually, we can be more specific and run this. We do something like that. We want the service that is running currently on the port 80. It's going to be the same thing, right? So this is how Apache is telling you that I have been installed successfully in your machine. Now let's continue with the instructions. The second part is installing MySQL and trying to host a single PHP page. Note that, just to remind you, Apache is a web server, meaning that it hosts websites, basically built in PHP. So if we can host Phpmyadmin, which is a very big, very large web application built in PHP, this means that we can host any single PHP page. And we are going to test that, right? Just a quick test. So I'm just going to start with installing My Sql Server. So I'm just going to go to my instance, right click, yes, Y, and enter. It's going to take some time. And it's done. Let's make this line here, let's just trigger the secure installation just to add some passwords and stuff like that for our MySQL whenever we try to access it. So let's press yes, or it's asking you for validate password, so just hit no. So I'm just going to write enter to skip this part. And let's set a password for our MySQL login. Remember at the beginning of the video when I tried to access MySQL from the command line, I need to enter some password. This is the password that we are going to create. So I'm just going to make 123, enter, 123, enter. Remove anonymous users. I'm going to skip that, enter. So disallow, I'm going to skip that as well, hit enter, and finally hit enter as well. Reload privilege tables, it's not necessary, we didn't make any changes, but we can hit yes, so Y and yes, and this is it. Now let's try to access MySQL from the command line. So I'm just going to maybe I should write this better. I don't know why is it. So let's try this. Yeah, I think for some reason the terminal or the command line doesn't like you to copy paste everything, so just try to type this like that manually and it's going to work. Let's enter the password that we just created, 123, and now we are inside the MySQL shell or terminal or command line. We don't really want to perform anything, I just wanted to try that everything is working, so we can hit Ctrl Z to get out of that shell. Now let's continue and install some essential PHP packages right? In order for us to be able to install Phpmyadmin. Okay, so I'm just going to install the PHP essentials here. So this line first, y enter, and the second line, I'm just going to pause this, and this is the second line here, so I'll just hit and right click. Alright, now let's restart Apache since we've made some dependencies have changed, right? So right click, and now we need to just make sure that Apache is able to serve any PHP page. So we can actually do this in multiple lines. So I'm just going to go to this directory. Alright, so I'm just going to copy this, and I'm going to hit there's no need for that, so cd to open the directory and right click. Okay, so this is basically the directory where any PHP file should be existent in order for Apache to be able to serve it or host it. Alright, so this is a folder, and this is a folder, and this is a folder. So we have entered like 3 folders inside of each other. Now I'm going to create a file. I'm going to make sudo nano. Nano is just the editor name, just like Visual Studio Code, and I'm going to create a script. This script doesn't exist, so I'm just going to create it in a spot that is called index.php. And now the editor opens, and we have the script, so we can write the following. So I'm just going to copy this, or let me just write it in front of you. So let's write some PHP code, right? So in Python we saw the print function. We can print as well in PHP using what we call an echo function. There is a print as well in PHP, but we don't really need to care about that. So let's focus on echo here. And just like any function, you can have the parentheses like this, and this is something especially for echo, you can just omit the parentheses, and you can just type whatever the string that you want to write. So I'm just going to say my first PHP website, right? And semicolon. It's like C++ and C, so you need to have a semicolon by then. Okay, but although this is a PHP file, from the extension, you need to wrap any PHP code inside what we call PHP wrappers, and these wrappers essentially have the syntax. So question mark or bracket question mark PHP, and you end these lines with a question mark then bracket. Now hit Control X, yes or Y, and then enter. Now this is the file here. So let's try to access this file and see, will Apache be able to serve it or not? So I'm just going to go to the IP address / the website route or the website name. So I'm just going to go, this is the IP address of my machine and index.php. And here we go. This is our website. This is the first ever PHP website that we make, and we were able to host it on Apache. Actually, since Apache is being installed in an AWS instance, which is on the cloud. It's on the cloud. So actually, you can make any kind of PHP website, right? And send that link. This is the link. This is the link for your website. Send that link to anyone, and he will be able to see this website of yours. But that's not a very that's not a website that you can be proud of. But that's a website, a PHP website that we have hosted successfully on Apache. Now let's continue and download the main interface, which is basically Phpmyadmin. So this is the installation for Phpmyadmin. Right click, Y, enter. It's going to ask you what kind of server, what kind of web server are you going to use to host Phpmyadmin. Now leave it as it is. Alright, hit enter since we want Apache. Now it's going to ask you configure database for Phpmyadmin with config dbconfig. Since then we are going to say yes for that. It's going to ask you for a password. I'm going to use the same password, 123, and hit enter. 123 for confirmation. Hit enter. And we're done. Okay. So let's just make sure that the MySQL is still accessible from the command line. Right click, 123, and we have entered. So let's go outside. Now let's reload Apache and restart the service. Right click, and let's copy that line as well, right? And finally, we need to tell Apache that I want you to host Phpmyadmin web application, right? So in order to let Apache be able to host Phpmyadmin, we need to tell Apache where is Phpmyadmin has been installed, right? So I'm going to open the configuration file for Apache itself. This is the configuration file, and we are going to copy this line, which is basically where a Phpmyadmin is installed, right? And go anywhere here. I'm just going to go to this line, for example, backspace to delete this hashtag. Hashtags here means a comment, and I'm going to hit right click to paste that line, and this is it. Now I have included the path for Phpmyadmin, so Apache can be able to figure it out where it is, and it can be able to host it. So whenever we hit after the IP address /Phpmyadmin, we should see something coming back to us. So I'm just going to go there, Control X, Y, enter. Okay, and let's restart Apache. Right click, and let's make sure that Apache or Phpmyadmin is accessible. So I'm just going to remove my index here, this index page that we have created, and write Phpmyadmin. And here we go. We have this. But the thing is, we never actually set any username or passwords. Actually, these username and passwords are configured in MySQL. Let's just go back to the slides. Remember, Phpmyadmin is trying to let you in MySQL DBMS, right? So whenever we have a username and password, this is basically meaning that the interface, this website, is trying to log me in the MySQL DBMS, and this means that I should have a username and password inside a table, inside one of the default tables that I've shown you before. One of the default tables, I think this is the default table, or this one, I'm not really sure. One of these databases, right? So we need to have our username and password that we will going to use to log in stored inside MySQL DBMS, and currently we didn't actually configure this anywhere, so we don't really have a username and password, right? So in order to configure these, we need to go to the command line in MySQL just for 1 second and do the following. So I'm just going to go there, and I'm going to open up MySQL from the command line. So let's just go there, enter 1, 2, 3, and now we are inside MySQL DBMS via the command line. Now we can copy this line, and this is actually saying that we are selecting the following columns from the database that is called MySQL and the table that is called user. So if we take a look here, I was logged out. By the way, this is a different instance that I'm just using to demonstrate what we are going to do in this instance here. So if we went to the table that is called MySQL, this is the database, I'm sorry. Inside this database, you're going to have so many things. One of them is a table called user, right? You can ignore all of these errors. So for me, I have a user called root, right? And I actually have a password for him. I don't know where is the password. I think it's this authentication string. It's just being hashed, so we don't really need know what is the password for it. All right. So this is what this means. We have a database called MySQL, and we have a table called user. And what Phpmyadmin is trying to do is, if we want to log in, it's going to check, is this username and password existent in this table, in this database, or not? If it's not, we are not going to be able to access the MySQL DBMS via Phpmyadmin from here. Okay, so this is what this line is actually doing. We are selecting all of these columns, right, from the database that is called MySQL, which has inside of it a table called user. And we are finding out what is the data under the user, the column that has the user value. See here, we have under the user column, we have a value called root. This is essentially us, right? So you can actually, this username is yours. That's the default username for anyone who is using Phpmyadmin. if he's the root user. But we don't really have any password for the time being, all right? So we're going to configure the password here. So let's just select the data that corresponds to us currently, and let's see how this is looking like. Okay, so this is our data here, right? What we are going to do is that we are going to alter, instead of this local, instead of this authentication socket here, we just want to have something called MySQL native password, right? So this is just a feature that allows you to set manual passwords if you want, or custom passwords. Okay, so I'm just going to take this, right click, and hit enter. Maybe I didn't put a semicolon by the end. Oh, let me just break out of it. And 1, 2, 3, right? And let me just make sure, yeah, that this is a mistake here. I should have included a colon or a single quote here. So I'm just going to edit this, have a single quote, so you don't really have to go through this whenever you are applying, right? Notice that you can change this password. I just want my password to be as simple as possible, but for security reasons, this might not be the best thing, right? So you can copy this in some notepad like that, and go there and change the password to anything that you want, like this. Obviously, I'm going to change the password after this video ends. So change this to anything that you want, like that, and just go to the terminal, right click, and you're going to see that query is okay. So we have changed the password. Let's take a look at the current data that we have here. So I'm just going to go to the query from before. Now the plugin is saying MySQL native. This means that we have set a custom password. All right, and finally, I'm going to flush all privileges to make changes persistent. And if we're done, then we are going to hit Control Z. Now we can go now and refresh this page and hit root, and then 1, 2, 3, and I'm in. All right, and we are inside Phpmyadmin. Now the installation is essentially done. What is left is that we need to install the MySQL node in Node-RED. All right, so I'm going to go to my flow and go to settings, to manage palette, and go to install, search for MySQL, and install the first one, which is basically Node-RED node MySQL, and install this. All right, if it's done, then close. Okay, and you should see the node here under storage here, so we can grab it from there. All right, okay, and before we do anything, before we make the connection actually to this database, we need to create our own database and tables. We didn't do that yet, right? So let's go to Phpmyadmin and go to databases, and I'm going to create a database that is called let's see, let's call it something like sensors, like that, yeah. All right, and create that database. Now let's create a table in this database. So from here, create table, I'm just going to make the table called readings, and how many columns should it have? This is basically one of the design decisions that you should make. In my case, I'm going to make it as simple as possible. I'm going to have a table that is called readings. You can have actually multiple tables, but this table is going to have an ID column, a light reading, since I'm sending light readings, and a column for created at, the timestamp when this actually arrives to me in the database. And finally, I'm going to have a column for the sensor name that is sending these values. All right, so they are 4. I'm going to leave it as 4 and hit go. All right. And these are the column, this is the structure of the table. These are the columns. It's flipped over, so this horizontal line represents the first column. This is the second column, this is the third column. So this is the first column. We're just going to make the first column called ID, right? And the values that it can hold of type integer, of course. And I'm going to hit on this AI, which means auto increment. So auto increment is going to set an index under this column that is going to be called a primary key. And if you've seen in databases course, you know that a primary key is just the field that makes this the entries or the values under this column unique, and we can use it to join multiple tables with, right? So it's a small numerical value that we can use multiple columns, multiple tables with, that is being unique in this table, right? So I'm going to create another column and I'm going to call it light reading. Notice there is no white spaces. Don't make any white spaces. So light reading like this, and this is going to be varchar. This is the type, which is equivalent to a string. You can tell from the hover here. Okay, and the length is going to be 255 characters. You can make it less than that. You can make it more than that. It's totally up to you. Oh, I'm sorry. The light reading is basically an integer. It's an integer. Okay, and let's make a column called created at with an underscore, and the type of this is going to be something called a timestamp, right? And the default value is going to be current timestamp. This is going to guarantee that whenever a row is created, the MySQL system by default is going to inject the current timestamp, the date, the hour, the seconds, and so on. Okay, and finally, let's just make this here. Let's make this the last one, or let's just leave it as it is. And finally, I'm going to make the final column that is called the sensor name, like that. All right, and this is going to be a varchar. The characters are 255, and then save. So this is the table. You can tell from this golden key that this is the primary key. This column is the primary key. Now if you want to browse the table, you wouldn't see anything here. So these are the columns, these are the headers of the tables, right? But we don't have any values. So let's try to inject some values. Let's try to use the GUI of the interface first. That's the easiest one. Since the ID is auto incremented by default and the created at is by default is going to get the current timestamp, we don't really need to provide any values for these two. So we can just care about adding a value for the light reading here. So I'm just going to say that the light reading is going to be 45, for example, and the sensor name is going to be called photo cell, and hit go. Okay, this is taking longer than it should. I'm going to pause this. All right, we are done. Now we can go to browse and check the current values. Now we have one row. See this? This is the first row under the columns here for this table that is called readings that we have created. This is the database and this is the table. So this is ID or light reading, created at, photo cell, and so on, right? Let's try to insert values, but from the using queries, right? Instead of using the GUI. So I'm just going to say, I'm going to say insert. You don't really have to make it capital letters, but that's the convention from back in the day, so I'm just used to do that. So I'm just going to say insert into, and that's the table name you are inserting into readings, right? Under which columns? Notice that these are the columns that we have. If you want to insert manually under all columns, which is going to be wrong in this case, you can just type all of the column names like this, created add, and finally sensor name. But notice, as we've said, the ID is auto incremented, so we don't really need to insert any values under this guy, and this is having a default value of the current timestamp, so we don't really have to insert any data under this column. So these are the two columns that we're going to insert data under. So I'm just going to use the values here, okay, values like that, and anything that you write in this column is going to be correspondent to the ordering of these columns. So let's say that under the light reading, I'm going to insert the value of 55, comma, under the sensor name, photo cell. And notice this is a string, so we need to wrap it between quotes. You don't really have double quotes in SQL, we have single quotes, right? So this is going to be under this column, and this is going to be under this column, right? Now semicolon at the end, and either hit go or control enter, and now the row is inserted, Now let's go to edit inline. You can go to browse, by the way, but we are going to see edit inline here. If you want to select or preview or project all of the values, all of the rows, so we can just say select all columns from the table that is called readings, semicolon. And it's going to tell you that the current all columns contains all of these rows. So select everything from this table. Or if you don't want to write this all the time, you can just go to browse here, and it's going to show you the same exact result. All right. Now, what we want to do is make these injections, instead of making these injections like that, instead of me going to the Phpmyadmin interface and write insert statements or use the insert GUI from there to insert values, we want to take these values from Node-RED, the values that is coming from this subscription node, and send it to MySQL, to my database, right? So let's configure this node here. So I'm just going to right click on this and this bin from there, and notice that this is the IP address of the MySQL server, and this makes sense. Why? We've discussed this before. This is the IP address of the AWS instance. So by now you should understand that MySQL server, Apache, Mqtt, Node-RED, all of them are on the same server, are on the same AWS instance. So that's why you can just leave it as this loopback address, or maybe localhost if you want. It's the same thing, right? Or even if you want to be more specific, all right, take the IP address and put it there. It's the same thing, right? This is the port where the MySQL server is running on, and this is the user and password name. So this is root, and password is 123. And the database name here, we named this to be sensors, right? So I'm just going to use that database, sensors, and add. I'm going to give a name to the node here, so I'm just going to call it MySQL DB. That's the name of the node. Now let's deploy to see if the connection is going to work or not. So we are connected to the database. This is good. All right, so I'm just going to make space for this guy here. Let me just make it at the end. All right. Okay, and let's take a look at the node itself. Let's see how can we actually write queries to this node. So you can see that there is a small button here that we can click. So let's click on the documentation, and it's going to tell you really clearly that there is going to be a topic variable that is going to be created on the message object. Remember, the message object is the object that is going to be forwarded through all of the nodes in this flow in Node-RED, right? So you need to create a topic object which holds the query that you want to send to the database, right? And if there is a result, in our case, if we want to insert into the database, there is no result, right? But if we are, for example, making a query that selects stuff from the database, since then this is a selection, then you are going to have some rows returned. So if there's a return for the query, it's going to be stored in the payload. If there isn't, then you don't really need to care about the payload. Anyway, so let's see how can we make a query to insert into the database, right? So I'm going to make a function here. Okay, I'm going to name it as insert. That's it. And the same query from before, I'm going to write it down. I'm going to put it in a variable called topic. This is a local variable in this function, by the way. So I'm just going to say insert into the same stuff that we have done from before, insert into the table name, which is called readings, right? Under the columns, which are, what did we name them? Light reading, and photo is or sensor name, and I'm going to send the following values, right? So the first value is going to be the actual reading, right? So the reading, notice that we are going to connect the value that is coming from this light subscription node into this function, and I'm not going to continue this. I'm just going to hit done for the time being. If I hit on this one, you're going to see that this is actually returning a message object, which we can actually see from there. So this is actually returning a message object that we are figuring out its payload. If it's greater than 60, then we hit something like exceeded for debugging purposes and stuff, right? So there is a message object coming from this node, so we can just use that, right? So I'm just going to have this here. Okay, so I'm just going to say that I'm going to concatenate to the values. I'm going to end my string here and have a plus sign, right? And I'm going to take that payload from the message object, right? And just to make sure, I'm going to cast it into a string using the parse int. This is a JavaScript function, by the way. Okay, just to make sure that it's an integer, since this column waits for integers. Let's just see the structure here. So this column, light reading, it's waiting for an integer. So just to make sure that everything is going to work, so this is the parse int. I'm going to hit plus, all right, and continue the string. This is comma, and then we are going to send the sensor name. I'm going to make it a static value for now, so photo cell. I'm going to show you how can you make global variables for this part. For example, if you have multiple sensors and just you want this to be dynamic, you don't want to actually write photocell or ultrasonic or whatever all the time, right? And close the bracket and semicolon here, right? And semicolon by the end, right? And just make sure that there is on this message object some kind of key, right, that contains this value that is inside the topic here. Okay, actually this doesn't have to be topic. We can call this something like query if this is going to make you confused. So this is the query. What really matters is that on the message object you need to have something called topic. That's it. All right, so that's essentially it. So let's hit and done. All right, and let's connect to this database, and let's see, let's go to the debugging node here and let's deploy. Okay, these are the current values that I'm receiving from my controller. So just to show you, these are supposed to be the current values. Alright, so there is a problem. Unknown field, photo cell. Let's see what happened there. Sensor name, photo cell. Ah, there is a problem. The problem is that photo cell needs to be a string. And remember, strings, we needed to wrap them between quotes like that, so we can just put quotes like this. So that's the error that is happening. This is just a string. So done and deploy, and hopefully there are no errors showing. So these are the values that we are sending to the Mqtt. Let's go to the database and hit browse. And I think it's working, so let's just make sure that it's working. I'm going to open up the flash from my phone and open this guy here. Okay, so it should be more stronger now, the intensity. Now let's refresh. Alright, and it's working. Alright, you can actually hit and show all, but I don't really recommend that, since it's going to show you, if you have like 10,000 rows, it's going to show you the 10,000 rows. This can crash the entire AWS instance, since we don't really have much storage in this instance anyway. Alright, so we are done with the inserting. This is essentially it. This is the part where you insert the database, and it's done. Now I want to create with you something like that, right? Something like in the dashboard, we can create a table that fetches the recent column, the recent row from the database. Notice in my database I have like 27,000 rows. So yeah, it can get pretty large sometimes. Okay, so let's see how can we do that. This is the flow. Before we continue, I just want to emphasize on one point. The table that you have, maybe you have one table, maybe you have a table for sensor, the sensor number 1. If you have multiple sensors, let's say that you have an ultrasonic sensor number 1, this is a table for it, You can make another table for the second sensor, call it, for example, readings 2, if you have another sensor like that. You can have multiple columns if you want. You can have a table for alerts, how many alerts are being triggered. For example, whenever here in the flow, whenever this function executes, right, or whenever these events execute, then this means that an alert has happened. So you can have actually a global variable that stores the number of alerts that happens, and from that global variable you can take the value and send it to a table in the database, or a column in the database in a single table. So you can have a column that is called number of alerts triggered, right? Or you can have like a column for alerts itself, right, which has a column of a table for the a table of the alerts. I'm sorry. In the table of the alerts, you can have a column, for example, the ID, right? It's auto incremented. Don't care about that. You can have a column for the time of the alert. When did it happen? The type of the alert. Is it an email? Is it a phone call? The value that made the alert happen, the cutoff value, and stuff like that, right? So you can make multiple tables as much as you can. I'm just going to stick to one in this video, right? So before we get to do this beautiful table in the dashboard, this is basically some HTML that I'm going to show you. I just want to tell you how can you actually make a global variable for this part. So instead of manually writing photocell, maybe the sensor name is not photocell, maybe it's something called ultrasonic or gas sensor, right? So we don't really want to make this fixed, so we can do something that is a little bit better than that. Okay, so in order to do this table here, we need to fetch the recent row, the last row in the database. Okay, the last row in the table in the database. Okay, so to do this, we are going to use the select statement from before, but let's just see how the select statement works one more time. So I'm just going to say select all columns from the table that is called readings, right, and hit enter. And now it's not going to show you all of the rows since we have way too much, so I'm just going to show all, and that's going to be a little bit ugly. Okay, we have like 133 columns, 133 rows so far, these couple of minutes. Okay, so in order to select the recent row, we can do the following. First of all, I want the recent row, right? So I want to order these rows. Let me just show you this one more time. I want to order these rows by the created at value. So I want the one that is having the greatest or the further, the most further created at time to be at the beginning, right? So let's try to order them by the created at column. So I'm just going to say select all from readings and order by created at, and let's take a look. And now you can see that the most recent ones come at the beginning. Yeah, no, this is ordering by created at, but ascendingly, right? So that's the normal order from the minute that they were created, right? So this is just a saying ascendingly like that, right? I think this needs to be at the end here. Let's try. So this is the same as doing that, right? So ascendingly from the minute that they were creating in an ascending order. If we write this to be descendingly, you're going to get from the minute, from the last one, which is basically, this is the time that I'm having on my machine. I have like 2 hours up front, right? So this is from the biggest to the lowest, and this is what we want. We want the recent one, which is having the ID of 174, okay? And in order to get the last one, only the last one row, we can just use something called limit 1, and this is it. You're going to have the last row, okay? And that's essentially my query here. So I'm just going to copy it and go to Node-RED, and I'm going to use another function. I'm going to call it select. This is just the function name. You don't have to make it capital. and I'm going to put this in a query variable. There's an equal, okay, and I'm going to put this query inside a variable called topic on message object, like that, and we are done. And let's take the values from this slide subscription, okay, and let's select this every couple of seconds. So I'm just going to use another trigger here, okay. So I'm going to use a trigger function that provides me or updates, see this table here, so it updates this table every 2 seconds with a new value. So where is it, where were we? Yeah, so wait for 2 seconds, okay, and send the message object, right, and after 2 seconds you can send the latest message object, okay. So this is going to update for every 2 seconds, and instead of connecting this like that, I'm just going to take from this, okay, so I'm just going to take from this and hit connect the trigger to that select function, and I'm going to use another query, another database node here. I'm not going to change anything in it, it's the same. Alright, but note that this time this database node is going to return something. Notice the documentation, it told you if the query in the topic, if it holds a result, the result is going to be returned in the message payload. Alright, so we would want to see the result here. So I'm just going to use a debugging node to debug the message payload from this database node. Okay, so let's deploy this and go to the debugging here. Okay, so this is the object being returned. It may seem a little bit weird, but this is basically a JavaScript object. Okay, let's make the trigger a little bit bigger here, 5 seconds. Alright, so this is a JavaScript object, okay, where it tells you that this object contains, it's basically an array, alright, that contains one element at index of 0. So let's see what is that element. This element essentially should be the content of this row, of the latest row, right? So I'm just going to say that whatever this array has, I don't want the whole array, I just want the first element of that array, so index of 0. And now take a look at this. Now you have an associative array, or if you want to call it a dictionary from the Python days, or an object in the JavaScript norm. So this is an object that corresponds to the values inside the current row. So let's take a look at this one here. So this is the row that we have, right? So it's telling you that the current value is at ID. This is the column name. That's the value under that column. That's the column name. The current reading is, this is the current value under that column. That's the column name. And that's the timing. That's the date, the hour, 11, half, hour 23, and the seconds, right? And this is the sensor name, which is photocell, right? So we need to publish this into a table that we are going to create in our dashboard that looks like that, right? So this is basically some HTML. If you found yourself intimidated, that's fine. This is the first time you might have worked with HTML, but it's really easy. So we're going to pick that HTML template, okay, and we are going to do the following. First of all, I would want to show you how this is going to look like. Okay, so let's remove this part. Okay, so you need to understand that in HTML, everything is laid out between an opening tag and a closing tag. Anything between brackets in HTML is called tags, right? So this tag here is called the division tag. So it has an opening and the closing. And you can tell that the closing tag is having this / before the tag name. So if you open the tag in HTML, you close it the same way, right? So a division in HTML is just a container type of tag. It doesn't show anything, it doesn't display anything, but this is just to say that I'm going to contain the following content inside a division, right? So I'm going to make a tag that is called table. Let's just write it in another way so it can figure out. Yes, table, and this is the opening tag, and this is the closing tag. A table is a tag in database that allows you, in HTML, I'm sorry, that allows you to create tables. It's as easy as this. So if you look at this part, you're going to see that there is a table header and there is a table body. So this is the table head. So inside the table, we have the table head, right, close, and underneath of it, we have the table body, close, like that. Okay, so in the table head, we have 4 columns. First of all, we have a row, of course, we have a row like that. So we have a row in the table head. This is tr or t row. So we have 1 row inside the table head or t head, right? Inside that row, we have 4 columns or cells or data cells, right? So we have 1, 2, 3, 4. So a data cell can be written as like this, td. But if the data cell was inside a row that is inside a header of the table, there's a more beautiful convention that you can use, which is th, which stands for a table head cell. So how many columns do we have? We have 4, right? So let's just create 4 of these sequentially. So the first value is called ID. The second is called light reading. Notice that this is just some text, so you don't really have to make an underscore. That's not a variable. And this is going to be created at, and finally sensor name, like this. Alright, and let's see how this is looking like. Now let's give it some size first. I'm just going to give it this size here. Okay, and this is it, done. Now let's take a look at the dashboard first to see how this is going to fit in and layout. And this is the table is going to be here. That's fine, this is good. Okay, now let's deploy this and take a look at our dashboard. So this is the table. It doesn't look the way that this is looking just because I'm having some styles. I gave this table a style. In styling, for styling a table or any tag in HTML, use what we call a CSS. So the CSS language is used to style the tags that are plainly created in HTML. I'm not going to go through how do we style this, but I just want you to copy the following styles and paste them, right? Since this is not really an web development course, so I'm just going to take all of these styles. I previously made this, of course. Okay, open this, right? And before the division tag, we are going to create a tag that is called style. And the style tag is used, it's not going to appear, by the way. This is not going to appear in the layout. But this is internally used by the HTML page, and whatever styles that you put inside these tags, inside this closing and opening tag, is going to be targeting the elements of the following HTML layout, right? So I'm just going to paste this. So I am targeting the table tag, and I'm giving it these styles, and I'm targeting the TD. We didn't actually create the DT yet. And I'm targeting the TH, which is basically the data cells inside the T head, and I'm giving these styles, right? So if we hit and done and went there, you're going to see that now the T head have these styles like that. Okay, now let's take whatever being returned, which is the message payload, right? And we care about the first element at index 0. We don't really care about the whole array. We just want the first position, the first element, the first row. So I'm going to take the same variable from there. I'm going to give it to that template. And now let's create our data cells. Inside the body, I'm going to use the same exact values since I have 3 columns or 3 headers. So I need 3 TDs under each one. Okay. So instead of T head, since we are inside the body, we need to have TD. And this is TD, TD, TD. Alright, and notice that the data cells needs to be inside a row, so I need to create a row first. So I'm just going to copy or cut all of these, create the row here, TR, Inside that row, I'm going to create or paste all of these data cells. Let me just indent this here. Okay, so I'm just going to put some static values. So let's say, for example, the ID is 300, the light reading is like 88, created at some date, I don't really care, sensor name is photo cell, like that, and hit done and deploy. And let's take a look, and these are the static values that we entered. Now we want to make these dynamic as possible. Alright, so in order to make these dynamic, we need to use the values that is coming from the message payload of index 0, which is basically these values. So we care about this associative array, or this object, the first element, the second element, the third column, the fourth column, and so on. Okay, so to use this, it's really easy here. In order to include any JavaScript or any variable, any JavaScript variable inside HTML tags in this node grid, we can use this syntax. You want the message.payload, right? So put the message.payload, right? And you will want the array. We don't want the whole array, right? We want the first position, the first index, which is basically this object right there, right? So we want index of 0. So in order for this to be actually getting or grabbing the values from this JavaScript variable, we need to wrap it between two curly braces. If it's a JavaScript variable inside an HTML layout in Node-RED, you need to wrap it between double curly braces. Now, this is going to return the entire object. We don't really need the entire object, right? For example, the first TD, which is under the first T head, which is the ID, I care about the first column, which is the ID. So I can just say from all of this object, get me the first ID. So .id, right? And I can do the same thing for the next one, right? So from all of this object, get me the light reading. So .light reading. And for the created at, it's the same thing. Dot created at, and finally dot sensor name, like this. Okay. All right. So let's hit done and deploy. And check this. So we have like a trigger of, I don't remember, it's 2 seconds or 5 seconds, but it's updating, you see. So if we picked up our smartphones and shed some light there, you should see this increasing in the table. Yeah, it's working. And this is the end of the 7th lab. One last thing that I have totally forgot to mention is that we need to go to the inbound rules and add the port for the database or MySQL. So I'm just going to write 3306 anywhere, and notice that you need to change this custom. You need to make it my IP for everyone, right? So you need to be able to be only your machine, your only machine, your machine or your laptop's IP address. It should be the only one should be able to connect to these to this instance or to any service of this instance from these ports. So change this anywhere afterwards. All right. So let me just save the rules. It's not going to affect anything, so everything should be working the same. Okay.